Welcome back to another live stream from Emerald Hill Skies. We're here on the outskirts of Louisville, Kentucky. It's about a Bortle 6 sky. Bortle is a rating we use to talk about how polluted the sky is with light. And, we're losing our dark skies all around the world, really. So let's guard the night sky by aiming our lights downward and using, just the light that we need. Anyway, here on the edge of Louisville, there's a big light dome, but I just thought that you might enjoy watching as we work through a typical workflow to be able to still observe a deep sky object, even though we're here in light polluted skies. So let's get started. In Astroplanner, we're currently, you can see our cursor is here on Uranus. So we're going to finish up the last object by making a quick observation. We'll say something like, loved how we were able to see the moons of Uranus. And then what we'll do is we'll go back to this live object here and we'll add a user image. Add a user image, and we're gonna, I don't know that you can see that user image loading, but when I click it in, you'll be able to see it because I'm just gonna call this Moons of Uranus. You'll see it there in the side view, and then we're going to go to the next object, which is the Pleiades. So we'll just right click and then slew that object. And as we slew, you'll be able to see the telescope outside, because the scope actually, that's a live view of the scope. You can see, by the way, the dew buster that's mounted on the top of that dovetail bar. You can see the lights blinking. That's I try to keep them set so that they blink on and off to light up that dew strip, to heat up that dew strip in front, so that it keeps the corrector plate on the front of the scope from covering up with dew. Let's go now back over to Stellarium, where we still are looking at the moons of Uranus. So now in Stellarium, to find the next object, we'll just go F3 and we'll say M45. And it has found the Pleiades, but we are really zoomed in on them tightly. So let's come back out away. And that's our field of view. Let's get a picture of where Pleiades is in the night sky. If we were to look due south, down here at the bottom is the cardinal compass point. Let me make sure you're looking at Stellarium. You are. There's the compass point for south. Now let's look up toward the zenith, and there's Pleiades. It's about 75 degrees up. So if you think about every fist is about 10 degrees, so you could count at arm's length roughly 10 or 7.5 fists would put you up at the Pleiades, looking due south. So now we'll zoom in, and that's where our telescope is aimed right now. I'll tell you what, let's center up on this object a little better. Let's find a star here in the middle somewhere, like about right there. Let's get a little bit zoomed in and let's find something more in the middle. How about Maya there, and see what this looks like. So what we're going to do now with Maya's center on Maya, it's a little bit too far. How about But if we center on this Maya Nebula, it's a little better, isn't it? But look how we're losing Atlas off the bottom of the frame. So let's find one down here. Let's center there. That's looking a little better. Even right here on this 13.5 magnitude star. Something like that. No, I think Maya's trying to find the exact center. And then what we can do with Stellarium. Let's go there. Now what we can do is we can say Control 0 or slew the scope to that point. And we're saying slew it to the current object. And it's going to actually move the scope now to this field of view. So we'll be more centered. I tell you what, last week we were in a live stream, and even though I was using a new way to control SkySafari, it still dropped out in the middle of the live stream and lost connection to the scope. And I don't know why it does that, but I tell you what, I'm just over it. I am tired of trying to keep SkySafari connected with the scope, and I'm really loving Stellarium. So let's go with Stellarium for right now. Here in SharpCap, let me move you over to SharpCap. Let's see, get you over there to SharpCap. There we go. Here in SharpCap, first let's go back out to full frame. Sure enough, here in SharpCap, we are at 5 seconds at a gain of 400. But with SharpCap, what we're going to try to do now is pick up not only these stars. You can begin to see the 7 sisters here. 1, 2, 3, 4. Whoops! I said I was gonna. When I'm pointing things out, I've got a new way I'd like to do it. This is the way I'd like to do it. 1, 2, 3, 4, 5, 6. I don't know what the 7th sister is, but those look like the 6 brightest stars. Would it be this one? Would this be the 7th sister? Or maybe these two? 1, 2, 3, 4, 5, 6, 7. Whichever 7 stars you see. You ought to look up and look at the Pleiades, as some people say, and see how many naked eye stars that you see. But at 5 seconds and a gain of 400, we're seeing a lot more than the 7. But notice we're not seeing any nebulosity. To see the nebulosity, let's drop our exposure down, make it a little longer exposure, and let's put the gain on 100, just so we aren't wasting any more grain. You know, we're not creating that extra noise in the exposures, the images. So once this, you see this green bar down here on the lower right. Let me make sure you're seeing that. That green bar is a little off of the image for you, but this is now working. This 30 seconds at 100 gain. So let's start live stacking this now. And we're going to clear the last live stack out. Takes it about 30 seconds for the first frame to come in. And at that point, we can start to do like a color balance. And we can also do a reset of the live histogram down here and do like an auto stretch just to get us started. Once again, when we pick up another frame, we'll maybe, boy, you can already see some of the nebulosity coming in. That's after just the second exposure. Let's do another. That's a much better color balance now. Let's move the black level over just past this peak. And let's move the mids over until the sky starts to pick up some of the bluish tint. And that's probably right about the place for where we are now. It's just 3 exposures of 30 seconds. I'm going to go put you back into SharpCap now so that you can enjoy a little better view and see the whole frame of what we're doing. So we're using this black level vertical bar, and we're keeping it just to the right of that peak, just to the right of that color peak. And then we're moving these mids over. And what that's doing is letting us see as much of that nebulosity as we can. So this is 4 frames of 30 seconds each. So this is a combined integration of 2 minutes. And look at the beautiful nebulosity. I'm going to get rid of this other stuff on the frame so you can see the whole frame. Look how this is not just an open cluster, but it's also a kind of emission nebula, as the open cluster is shining through the dust lanes that are here in this open cluster. And some of that, let's just find out if I go to see, here we go. Messier 45. I'm curious if this is maybe not just an open cluster, but also look how it's reflecting through that interstellar dust. And so we get what might be called a reflection nebula in a way. So it's not just an open cluster. It's also a kind of nebula that we're seeing as well. And maybe this dust is left over from when the stars were born, or maybe it's just dust that the open cluster is passing through right now. But either way, these hot blue, and that means they're extra bright and extra powerful, these hot blue stars are lighting up that dust with this nebulosity. And most researchers think that this dust cloud is kind of unrelated, especially now in modern astronomy. Used to, people thought that this dust was traveling with the Pleiades or Pleiades. Let me just check and see if you're able to see that in the frame. Yes, I think you are. So this dust is one of the most beautiful parts of M45, Messier 45. Now, when Messier used to see these objects in the sky, you know the story, he first of all wondered if they were a comet, and he was sad afterward because they didn't move in the night sky. With the primitive telescope that he had and the lights of Paris, he didn't have a light pollution filter like we're using tonight. The Celestron light pollution filter that's made especially for the RASA 11. He didn't have a light pollution filter. And from atop his hotel perch in Paris with those lights, he would wonder if this was a comet. And once he knew it wasn't, he created this list called the Messier catalog so that he wouldn't get confused anymore the next time he saw this blob. Well, part of this blob is this open cluster, but another part is the beauty of this nebulosity that we're seeing. Let's bring our live stack back up now into view, and let's see what we've got. So with 5.5 minutes, we're going to call it. That's enough to be able to see some of the beautiful nebulosity that's here. Let's wait till the last frame comes in since we've been capturing it, and this will give us 6 minutes on M45. So this is the way electronically assisted astronomy works. It really is caught up in the observing of the object, and it's enjoying the beauty of this night sky object, not so much with post-processing. I was watching an astrophotographer yesterday, and he admitted that he spent twice as long in the post-processing than he did capturing a typical object. And on a typical object, he would spend from 2 to 6 to 8 hours, and then he would spend 16 hours processing. And what we're doing here is real time, capturing the object to be able to enjoy it, saving an image of it just so we can be able to remember it. And then what I'll also do is I'll save a screenshot of it. And boy, in this case, the screenshot is almost the same size as the full frame. The RASA 11 is perfectly matched for this particular object. The frame is just perfect. So what we do lastly is we go back to Astro Planner and we log our view of what we just saw. So we'll say here, right click, make an observation, and we'll say, wow, we could make out lots of nebulosity after just 2 frames, captured 6 minutes, and it was gorgeous. And then we'll go back here to the Pleiades list, and we'll say add a user image, and we'll go ahead and grab that screenshot that I made, and we'll call it 6 minutes on 2011-11-08. And then when we save that, you'll see that pop into that frame. So there's the new frame we took tonight, and we'll save it. And that's an entire cycle of one object, at least the way we do electronically assisted astronomy here at Emerald Hills Live, Emerald Hills Skies. If you enjoy this kind of content, I hope you'll subscribe, and maybe if you don't mind, click that thumbs up. And what that does is it helps other people find the channel. We sure appreciate you being here with us, and once again, we especially appreciate God and the way He makes these beautiful objects for us to be able to see. Thanks for the fact that you've spent this time with us. We don't take for granted. You could be looking at a lot of things, and I appreciate you spending this time with us tonight at Emerald Hill Skies. We'll see you next time.